Hi everyone, I'm Esa Meetika from the Department of Computer Science and Engineering, and I have developed a radar system using Arduino Uno. So the main objective of my project is to design and implement a radar system which utilizes an ultrasonic sensor for accurate distance measurement and a servo motor to sweep across a specified range. Here we have given the range is 1 meter, and the detected distances and angles will be dynamically displayed on the computer screen in real time. This project aims to demonstrate the principles of radar technology and its application in the obstacle detection. Moving on, the components we have used here for hardware, we have used servo motor, Arduino Uno board, jumper wires, ultrasonic sensor, and breadboard. And for the software, we have used Arduino IDE and the processing IDE. This is the main circuit diagram of our project. As I have said before, there are three main components: Arduino Uno, ultrasonic sensor, and the servo motor. So for the Arduino Uno's 10th and 11th pin, the echo and trick pin of the ultrasonic sensor will be connected, and on the 12th pin of the Arduino board, the main pin of the servo motor will be connected, and the 5-volt and the ground pin of the Arduino Uno board will be connected to the breadboard and will also be connected to the 5-volt and ground pin of the ultrasonic sensor and the servo motor respectively. Moving on, let's just go to the Arduino Uno's code. First, we are including the servo library, and then we are defining the values of trick and echo pins of the ultrasonic sensor to 10 and 11, which are the pins of Arduino Uno board. And then we are having two variables called duration and distance, and then we are creating an object for servo motor, and then we are having a function called setup, which is used for setting the pin mode. The trick pin is basically the transmitter pin, so it is set as output pin, and then we are having echo pin, which will be set as input pin, and then we are beginning the serial communication after 9600 millisecond, and then we are attaching the servo motor to the 12th pin of the Arduino Uno board, and then we are having a function called void loop, which is basically used to rotate the servo motor from degrees 15 to 165 and the reverse 165 to 15 respectively. So for the first loop, the servo motor will be delayed by 30 milliseconds, and the distance will be calculated using the calculate distance function. And using the serial print function, we are going to send the current degree and the current distance into the serial port. The first for loop will again be repeated for the 165 and 165 to 15 degrees. And then we are having a function called calculate distance. Using the calculate distance, we are going to calculate the distance measured by the ultrasonic sensor. Using the digital write function, we are first setting the value of trick pin to low, and then we are setting the value of trick pin to high, and then we are going to calculate the duration using the pulse in function, and using echo pin, which will be saving the sound wave travel time, and echo pin will be set to high, and using the pulse in function, it's going to calculate the duration, and using the distance variable, we are going to calculate the distance by sending the value of duration into this variable and multiplying it with 0.034, which is basically the sound velocity of the sound divided by 2, and then we are going to return the distance. This is basically the entire code of the Arduino. So moving on, this is the computer screen displays code, which is going to fetch the data from the Arduino Uno board and the ultrasonic sensor. This is basically written in the language called Java and using the IDE called processing. So first we are going to import the necessary libraries, which are serial, key event, and IO exception, and then we are defining an object for the serial, and then we are going to have the necessary variables defined, which are angle, distance, data, and index 1 and index 2 respectively. So for the first function called setup, we are going to set up a screen with a resolution 1200 to 700 size, and then for port, we are creating an object for new serial. We are going to create an object for serial with the port number, which is the same port where our Arduino is running, and then we are going to use a function called buffer until, which will read the data from the serial port up to the character dot, and then we are having a function called void draw, which is going to simulate the motion blur and slow feed of the moving line, and then it's having four functions called draw radar, draw line, draw object, and draw text, which will be covered next. So before that, we are having a function called serial event, which is used for reading the data from the serial port, and the data will be stored in a variable called data, and there are two main datas which will be fetched from the serial port. They are angle and distance. The angle and distance will be fetched as string, and then it will be converted to integer, And then we are having a function called draw radar, which is going to display the entire starting coordinates of the new location, the ending coordinates, and all the lines inside that particular screen. And then we are having a function called draw object. This function will be activated when we detect an object using the ultrasonic sensor, and the strokes will be displayed as red line inside the computer display screen. And then we are having a function called draw line, which is going to be used for starting a line from the angle 15 to angle 165 and moving on between these two angles. And then we are having a function called draw text, which will be used for displaying the text. There will be two texts, which are distance and angle, which will be displayed based on the data fetched from the serial port, and the line will be moving accordingly based on the distance and the angle. So this is the entire processing ID code for our computer display screen. Firstly, we are going to run the Arduino Uno program, and then we are going to run the processing IDE program. After you click run on processing IDE, it's gonna show you a page like this. The radar will detect the object based on the distance and the angle. And after it's rotating from 15 to 165 degree, if there is an object in its place like this, the distance of the object and the angle of the object will be displayed in the screen. So if we place an object like this, it will show you the object distance. So that is basically the demo of our radar project.